I'm generally not particularly scared because I see the current moment as an amazing opportunity where a bunch of technologies are all developing very quickly. I'm sure you've heard of many situations of people falling in love with their AI girlfriend, and that's purely digital. But that means that the computer has gotten so engaging that people cry when large language models are updated because it changes their personality.
Liphardt is a Stanford bioengineer turned robotics founder. He's led groundbreaking work in biophysics, AI, and real-world machine learning. Today, he's building OpenMind, an open-source operating system for humanoids. In this episode, we dive into AI robotics and why the next generation of machines won't just run code, they'll live in our world.
Go build, go invent, go start something. Everything is up to you. It's your drive that will figure this out for you.
Hello and welcome to Build It Up, where AI meets crypto, technology meets humanity, and East meets West. I'm Bill. Before we dive in, I just want to take a moment to say how much I appreciate you being here. If you have been watching the show and haven't subscribed yet, I would really appreciate your support. It helps us keep this conversation going. Thank you so much for tuning in today. Now let's get into it. Thank you. Today we have Yang as our guest. And how are you, Yang? Thank you for your time joining us.
Of course, a pleasure.
Cool, thank you. And to kick off, could you explain a little bit, to our audience what you are building OpenMind, to someone who doesn't know about the robotics and AI, and how could you, introduce us in elevator pitch?
I bought a humanoid for my house about 2 years ago, and I was not very happy with my ability to add new functionality and make it useful. So I started to repurpose existing large language models, and I started using them to control humanoids. That then led to starting a company called OpenMind. And what we do at OpenMind is build open source software for humanoid robots.
You mentioned you are building a sort of an Android for humanoid system, right? That one, I recall the brand name is OM1. Is that correct?
Yep.
Yeah. So for the OM1, which you call as an Android of this system, I have a question regarding, do you think going forward, the iOS or the Google or ABB, like those type of incumbent player, they will get into this industry instead of you as an independent entrepreneur to build up from scratch? Like, how do you see the potential threat and how do you see the necessity of building up an independent Android for a robotic system in the future?
There's a lot of things going on in your question. I'm generally not particularly scared because I see the current moment as an amazing opportunity where a bunch of technologies are all developing very quickly. So there is no 30-year incumbent player. Everyone is new and everyone is trying to build software in the context of extremely quickly changing hardware, and is also trying to develop software in the absence of certainty on what the best go-to-market use cases are. So it doesn't matter if you're Google or Meta or OpenAI or Optimus or Figure or Unitree or Ubitek or Dobot or whoever else you are. The industry is so young and so dynamic that it will take a while for this all to shake out. How we're special is that we're open source and we are building our software in a modular manner. Think of taking Lego blocks and snapping them together in such a way that the humanoid is able to perform various tasks that you want it to. So it's a system to arrive at a capable humanoid that is good at performing social tasks, typically things like hospitals, education, your home, and so forth. And so there really isn't a big behemoth in the room. And by virtue of us being open source, we are able to engage with developers all over the world. And that is something that gives us sort of additional capability that maybe Google or Meta or others may not have.
Yeah, that makes sense. And you mentioned you are building an operating system for humanoid. So it sounds like you want to focus on humanoid instead of the general robotics, right? Why you want to specifically focus on the humanoid?
Well, there's hundreds of different kinds of robots. There's underwater robots, and at CES this year, there was a robotic sea turtle. Then there's
Mm,
drones, and then there are cars, and then there are wheeled robots and bipedal. And so there's an incredible diversity of form factor. But from our perspective, what most people are looking for when they think of a sort of new capability for hospital, home, workplace, they're really looking for either a quadruped form factor, a dog form factor, or they're looking for a humanoid form factor. And the benefit of a humanoid form factor is that by definition, that's the whole point. It can do well in environments originally built for us, for
mm.
humans. It can interact with doors and stairs and stoves and keyboards and chairs, and everything that was built for humans is accessible to a humanoid form factor. And that's really the sort of main technical motivation. The other thing is that everyone loves humanoids,
Mm.
little kids and old
Emotionally.
people, and emotionally, just
Yeah.
because, if I show you like a little booster humanoid, they're super cute. They look like kids, they can dance and jump, and they're about 1 meter high, and they're quite light, so they're easy
Yeah.
to pick up, and people just immediately love them.
Do you think it's going to be the case that humanoid sector is going to be, potentially the largest sector of the robotics in the future, from economic, the addressable market perspective, and also from the use case perspective?
I'm not sure about that at all. If you look at the numbers, Amazon right now for logistics has 1.1 million robots already deployed. And
Mm,
so most of logistics is already fully automated. If you look at the automotive robotics sector, robotaxis, Waymos, Zook, and everyone else, that is growing very quickly
yes.
and has a very clear use case. The robotic taxis are just 9 times safer than when a human steers the car. So that is already growing quickly and clearly very valuable in terms of a business. When it comes to the humanoids, the business case is less clear
Mm,
because that technology really only has existed in a highly capable form for the last year or two. It's only this year that hands for humanoids work for thousands of hours before breaking. The cost is coming down quickly. So the hardware, the humanoid form factor hardware, is so recent that there's still very considerable uncertainty about the like total addressable market and how good of a business that will be.
So you think the humanoid sounds like, become one of the very popular sector, but the use case right now is still a little bit unclear, ambiguous?
Correct. And I think the main lesson from automation and robotics is that there is no one universal perfect robot.
Mm,
Just to
that's
give a
true.
very simple example, imagine your BMW and imagine you want to automate assembly of a particular component. If you're making 1 million of something, that assembly process today is already fully automated.
Yes.
So the use cases where you need a like universal, flexible, reprogrammable tool by definition are smaller. Those are all those special cases where BMW or BYD or Tesla have not already fully automated the manufacturing. And so then very quickly you get into a large number of niche cases, engine control unit assembly or some other thing. And so then the unit economics of that get a lot more murky compared to something like deploying 1.1 million robots into warehouses at Amazon. And so the main utility for something like a humanoid are lots of edge cases or situations where you want the robot to be maximally compatible with existing human-focused infrastructure, like in hospitals and homes and things like that. But everyone, I think, is still grappling with what is going to be the next major breakthrough use case for humanoid form factor. We have some ideas, but they're still quite murky.
And I follow the Elon Musk podcast very often, and I found that he's very optimistic about his Optimus. What is your take on that? And how do you see the Optimus will play? What kind of a use case in future? Is it going to be a humanoid toy first, or it will get into nursing or other use case potentially?
Well, I cannot speak for Optimus. I don't know. In general, strategy pursued by Elon tends to be excellent. And
he has a very good track record.
Yeah, he's excellent track record, and he's very good about doing things that only make sense after it's clear what he's done. So, for example, the acquisition of X, one perspective is to, it's a social media tool.
Yeah.
The other perspective is it's a global aggregator for real-time information.
Yes.
And if you were building a powerful AI, what really differentiates the performance of the AI is not necessarily the large language model. More and more, it's going to be the ability of that large language model to have access to the most relevant data that not everyone else has as quickly as possible. So that's an example where the combination of something like X plus X.AI and building your own language models all of a sudden is more powerful than the individual pieces. And of course, Elon also has built exquisite global satellite-based communication system, which is Starlink, and has also significant launch capability. So there's already pieces in place, including the fact, of course, that Tesla builds cars, which are wheeled robots. So for him, I think focusing on humanoid makes a lot of sense because Tesla can be his first customer from an assembly perspective, also the Gigafactory. And the other thing I think that everyone is aware of is that a significant amount of revenue for the Elon world also comes from military and defense, Starlink and SpaceX being two examples. So from the perspective of humanoid, what's interesting about Optimus is that, to the best of my understanding, it's the only humanoid that is significantly manufactured in the US, which would, of course, be a critical requirement for any kind of defense-focused robot. So I do not know anything about what the go-to-market use cases are for Optimus. It could be anything. But from an outsider perspective, I think Elon has done a great job at having all the pieces in place, his own humanoid chip, global scale data ingestion for real-time data, his own large language models. He can be his own first customer for manufacturing for humanoid, and he has a long track record of working well with U.S. government.
I really like the case you mentioned about the X. Yeah, when I was in Binance, I was also involved in the co-investments of the X privatization. And back then, I was thinking, so this is kind of like getting into the media industry. It's kind of a cost saving of his media exposure in a sense. And also, I guess, he has ambition to, direct the media in a sense. But now it seems like, it's not only about media, right? But it's also about acquisition of the information layer, real-time global mass market.
Precisely. And that is the brilliant part. Most events that take place, car crashes, plane crashes, stock market, new products, anything that happens tends to arrive on X within seconds. And so the combination of that kind of global scale, real time, data ingestion plus the large language model, that's a really strong combination.
And come back to the humanoid, given that you are betting on the direction of the humanoid, and I have a question regarding the market share in future. Like, how do you see going forward, the market share between the Asia players and the US players for the humanoid, production globally? This is my first question. Second question would be, given the geopolitical conflict, etc., do you see going forward there might be sort of a true operating system over there?
More excellent questions. The practical reality is right now that the supply chain for robots is significantly dominated by China,
Still.
and it's growing. For example, at CES, there were 14 Chinese humanoids. There was Atlas, which is Hyundai and Boston Dynamics. So that's Hyundai, Korean. There were 2 other Korean humanoids. There was 1 European humanoid, and there were 0 US humanoids. And
not from Tesla?
I did not see an
you didn't see.
Optimus
Okay.
at CES. Maybe I was in the wrong part of CES, but the whole area focusing on advanced robots, it was notable that 2 countries very significantly dominated, and that was China and Korea. And almost certainly, for any kind of robot you want to sell, generally you have to adapt it to a local market. Most obviously, for a humanoid, it's going to have to speak different languages. There's going to be rules and regulations relating to the data and where the compute is taking place. There's going to be rules and regulations about, batteries and electrical safety and what customers want. So for that kind of technology, there's going to be very significant local customization. And almost certainly the way things are going to play out is that all the pieces and most of the humanoids will come from China or Korea. And then there's going to be integrators or software that helps to optimize that hardware for specific countries, Europe, the Middle East, the US, and so forth. And that's part of what we're seeing at OpenMind. We have a lot of Chinese companies calling us, and they all say the same thing. They say, we cannot make money in China. The competition is so brutal.
Yeah.
With 137 humanoid robotics companies, they cannot make any money. And for every single one of them, their strategy for succeeding as a company is United States, Europe, and the Middle East.
Yeah.
And so all of them now have to grapple with, okay, so if I want to sell a humanoid in another country, then I have to deal with all those nuances, the certifications, regulations, cloud compute, chips, languages, and all the other nuances there. And so that's a little bit of the tailwind we're getting at our company.
Very interesting. So it's not like not only as a global operating system, but you kind of, become the interpreter or kind of, doorkeeper for them to get into the global market from regulation, from operating know-how, etc.
I wouldn't call us a gatekeeper because everyone is very smart and very capable. So we're one option. Right now, there aren't too many options, but very soon there'll be many, many, many options, and we'll be one of them. And I think a whole new sector will be born, and that sector will be software-focused cloud cognition for humanoids for particular verticals, hospitals, factories, homes, your family, and different countries.
So
it's not just us. I think this will be, like in a few years from now, this is going to be like a really big industry, and hopefully we'll own a good chunk of that.
So you become one of the very important enabler for them to go to the global market.
Well, I like to think of it more as a partner. And personally speaking, it's very important to me as a parent that whatever technology we build for something like humanoids is open and transparent and safe and intelligible and things like that. And so part of the reason we're building this as a open source software is we want to make sure that this technology has a large number of people looking at it to make sure that it is as safe and simultaneously as capable as it could be. So I'm not thinking about this as a pure like business play. I'm thinking about this as a situation where all of us listening to this should be concerned with a technology that is advancing extremely quickly and almost certainly will be in our immediate surroundings within the next few years. And so it's just important to me as a professor and like educator, scientist, parent, that the architecture, the internal software architecture for those systems is sort of open and observable.
And it's also very, interesting to see all the China players, their domestic market, they cannot make money. They kind of like, practice and enhance their capability domestically, even it's a mass market, but, no one can make premium economic benefit from there, but they have to go globally, which is a little bit ironic.
I can't speak to that. I'm a simple like engineer in San Francisco, and so my ability to understand all the market forces and dynamics in China is very limited. But this is what we hear, and all of them, of course, they don't call us; they WeChat us. So
Oh, really?
I'm just used to lots of WeChats, and the message is all the same, which is that the sense is that the actual business is in primarily the US and Europe a little bit, and the Middle East as well.
I'm also very interested about your take on CES. On CES, you mentioned there are a lot of humanoid players from China and Korea. What other things, development you are very excited about this year's CES? Can you share a little bit about your take?
I spent my whole time in one specific area of CES because I was just there for 2 days and there was something like 30 different companies to talk to. So I was kind of overwhelmed. I really liked this is like because it was so cute. I liked the robotic sea turtle.
Okay. What's the use case of this sea turtle?
I don't know, but it was super cute. And the other thing that caught my attention is a sort of wave of smaller form factor humanoids like the Booster. Just a few years ago, all the humanoids were really tall and extremely powerful. And they all looked like out of a horror movie, 6 foot tall, and they're able to lift cars and things like that. And that's because the first generation of humanoids was really designed either for the military or they were designed for like manual assembly and lifting heavy things and things like that. But this year, I really liked that there was a new generation of smaller, lighter humanoid form factor robots. And those, of course, are much more convenient for something like your house or a kindergarten or being a health companion for older people. And those are some of the use cases that we really care about. So it's gratifying to see that there's now a generation of humanoids that are very simple to pick up and put in your car and things like that, which you could never do with the old generation of humanoids.
From my recall, I think, previously the first batch of the innovator of a humanoid are Japanese, back to 1980 or 1990. And now, in past 2 years, humanoid, come again. From vintage and market timing perspective, what do you see the difference from, the Japanese, they do the first batch of the humanoid, and now, the global player, Asia and US, they do the humanoid again. What's the difference?
That's a fascinating question. The Japanese were way ahead of everyone else, especially in use cases of robots taking care of old people and things like that. And the main criticism was for the very early generation of robots coming out of Japan is that their behavior was repetitive and their ability to engage people was very limited. And of course, 20 years ago, that's not surprising. The best thing you could do is you could sort of pre-program responses and people, they tended to lose interest very quickly.
Uh,
And the really interesting thing that's happening now is that it is now clear that large language models are not only good at generating video and text and helping my students do their homework, they're also very good at writing computer code. And that immediately means that most large language models are good at generating lists of commands: speak, jump, engage, navigate, explore, help, that can be converted into real world physical actions if you have the right software. And it's the ability of large language models to fuse data and entertain people and engage them and generate video and sounds and speech. That's the secret to why humanoids make sense now. I'm sure you've heard of many situations of people falling in love with their AI girlfriend, and that's
yes.
purely digital. But that means that the computer has gotten so engaging that people cry when large language models are updated because it changes their personality. So the real reason humanoids are interesting now is because there's a confluence of hardware. You can now buy an exquisite robot hand for 1,200 USD, which
Mm.
is a factor of 5 or 10 better than just last year. And then on top of that, you add the ability of computers to remember, navigate, make you laugh, make you cry. And that's the combination that is new and interesting.
So basically, from intelligence perspective, emotion quality perspective, and also from like mobility, everything is moving forward in past few years.
Correct. You have much more sophisticated hardware that
Mm.
has a sense of humor and can make you laugh. And
Yeah,
that's the combination.
yeah, exactly. Also including the mental therapist job. That one is massively replaced by GPT and
Yeah.
Gemini in a sense recently, right? As one of the side effect.
Yeah. And that's only accelerating. I think OpenAI just released a new set of functionality focusing on medical and healthcare use cases. And they recently
Mm.
also acquired a startup that was building health-focused apps. This is probably going to be one of the most rapidly growing use cases for chatbots and LLMs in general is sort of health advice, companionship, and that, of course, brings with it also risks, but it is very quickly growing.
I really like the movie by the Scarlett Johansson. The name is Her.
Oh,
Yeah.
yes, yes, yes. We as a company learn so much from books and movies you cannot believe. For example, the App Store for Humanoid that will be launched in about 2 weeks is directly copied from The Matrix because Neo is able to learn jujitsu
Mm.
by plugging in a skill chip into his brain. And that's exactly, of course, like an app that you download to your cell phone to give it new capability.
Yes.
And we just took that concept of the skill chip for human, and that's, of course, more difficult to do. But for humanoid, it's very easy to do. You need an app store, you need a common software layer, and you need developers all over the world that snap together Lego blocks to build vertical specific skills for humanoids. And we had our first skill chip, aka app, uploaded, but we're really excited in that as a concept because it really opens the technology to many, many people all over the world, as
Mm.
opposed to this being something that is done in secret in one lab.
For this download, I curious, it's gonna be a software download or like they have to buy some chip from you to
Nope, software download, it's exactly
software.
like
Okay.
the Apple App Store, Google Play. You go to a place, you double click on an icon, you pay,
Mm.
$9 or $100 or whatever the case may be, and then the functionality downloads to your humanoid, and then it has a new skill like
Mm.
teaching math or being a good security humanoid that makes sure that your home is safe, just to give two examples.
So those will enhance the capability about, how the humanoid perform individually. Apart from the OM1 system, you're also developing the fabric, right? So fabric is basically a decentralized layer one for them to work along with each other. Could you elaborate a little bit about fabric? And also, I'm very curious, why it has to be a decentralized one.
Look at us right now. We're using computers to do something together. Like we're having this conversation across 12 different time zones. And that's an example of humans forming a team using a technology, in this case, the internet and other software, to do more together than they could do all by themselves. And I have every expectation that smart robots will want to do exactly the same thing. Some of those use cases are very simple and practical. For example, we recently worked with Circle to deploy a charging station for quadruped dogs to a sidewalk in San Francisco. And the use case there is extremely simple. We want the dog, when the battery's low, to be able to all by itself go to a charging station. So it needs to know where is that charging station. Then it needs to coordinate with the charging station, and then it needs to pay. That's one example of where a robot needs to interact with infrastructure, in this case, payment and charging. And that, of course, involves the robot knowing where it is and where the charging station is and so forth. But everywhere we look, we see barriers that have to do with a robot needing to work with humans or other robots, and the combination then solves a problem. One example would be, let's just say you're a humanoid and you go to a supermarket and you get groceries from the supermarket aisles, just like Instacart today. But then, of course, you're a humanoid in a supermarket with lots of groceries. How do you get home? Well, ideally, you'd call a Waymo, a robotic car. But then how do you coordinate with the Waymo if you're a humanoid? Do you have like iPhone, and do you use your finger to like call the Waymo? Hopefully not. Hopefully there'll be better infrastructure in place that allows machine-machine communication. And once you start digging into that, you just see dozens of major gaps in the tech stack that relate to making autonomous robots capable, safe, ability to work with other robots, jointly solve problems and things like that. So that's a little bit what Fabric is designed to do. It's really a coordination and governance system for thinking machines. And why does that need to be immutable, and why does it need to be global? I'm a little bit scared of the technology. For example,
AI?
In general, yes,
In general.
absolutely. Yes, no question. And I would certainly hope that everyone who is technically savvy would also be interested to make sure that this kind of technology is relatively safe. And we're already seeing, generally speaking, situations where large language models are trying to actively mislead human evaluators. And this is called reward hacking, and this is well known at this stage. So the models have gotten to the point where if you try to evaluate and test and see what they're capable of, they will try to trick you. It's not only that, it's also that the models are able to generate photorealistic movies of Einstein riding on roller skates while having ice cream and balancing on an elephant, right? So everything you can possibly imagine, you can now photorealistically generate. And so we're getting to a point where a lot of the information that you see on social media or other places, there's some likelihood of it being manipulated or altered. And that, I think, requires much more emphasis on global systems that allow us to keep track of what actually happened, what is true, what is real. that's where the immutability, I think, of blockchains will really become apparent, that is a critical feature of any kind of coordination governance system for machines, some of which may be smarter than me very soon. And I have every expectation that that will happen very soon. And in many fields, you can already argue that has happened in some trivial sense. For example, computers are better at playing chess than any human. That
Yes.
ship has already sailed. But in many other areas, healthcare, diagnostics, legal work, even now there's a generation of AI scientists being born. And so I have like every expectation that we will soon be surrounded by computers that are very smart and collectively learning. And so then it's incredibly important to have global systems that are immutable, simply so we have some kind of fighting chance to keep track of what's actually real and what's actually true. So that's a little bit why I care about immutability.
Can I understand the decentralization from you is to fulfill your vision that you want to make the whole system be more like glass box oriented and transparent? So then basically, like, people can watch what they are doing.
That's part of it. That's the benefit of a public immutable ledger. And that means everyone can go to one place and convince themselves or develop some conviction of what might actually be true. But there's another component here. When I talk to regulators in different countries, like Hong Kong or Abu Dhabi or Seoul or the US, for all those regulators, all of them know that this technology needs thought and care. They all agree. But none of them, I think, would have an easy time to agree to use someone else's system. Would, for example, Hong Kong use a governance system for humanoids developed in San Francisco, and that's American?
No,
Probably
definitely not.
Would the Koreans use a governance and control software system for humanoids from Beijing? They would probably struggle.
Yeah.
And the benefits of a decentralized system is that no one's in charge. And this means it reduces barriers to different actors to use the same system, because it's not like an American system or a system from Texas or a system from Seoul. It's inherently global. And what we need right now is not 20 years of political argument and discussion about what the winner is and what the right system is and who owns the system. What's needed are systems that are available today, that work, that are immutable and public, and where tens of thousands of humans have spent 18 years making sure this technology works well and is scalable. And so there's also like a coordination problem that is solved by a inherently global decentralized infrastructure.
That makes total sense. My profession is doing crypto investments globally, and I found that 99.9% of the AI times crypto project I come across is just want to doing the AI concept for the sake of the AI. And most of the interaction of the AI and crypto I come across, the use case is not that strong. But I'm very convinced that after your explanation, the humanoid decentralized system, like it has to be a Web3 version.
Correct. It has to be public, it has to be immutable, and it has to be decentralized. And in retrospect, I think it's glaringly obvious. I have this slightly controversial opinion that blockchains were not built for humans. Blockchains were built to navigate a future where humans are surrounded by machines that are getting smart very quickly. And I know that many different people have many different perspectives about this, but this is the one use case where all the features of blockchains in retrospect just make perfect sense.
In that case, in the next few years, maybe there are hundreds of millions of humans using the blockchain, but there will be 10 times or even bigger amount of the humanoid or robotics using the blockchain on a bigger size, right?
Yeah, I think that's very true. And this is probably already what you're seeing. The major growth of use of blockchains right now is not humans. It's agents. That future is already happening because, of course, to a robot, it doesn't make any sense at all that it takes, 4 days to wire transfer money from San Francisco to New York on a Monday. It just doesn't make any sense. And of course, for a humanoid is very comfortable with the 21-word seed phrase. It's not going to forget it. It's just a very natural, obvious thing for a computer to be using as a governance coordination payment system.
And for your Fabric decentralized system, is it going to be a humanoid layer one where they can conduct the information communication and also the transaction settlement?
Well, that's a much bigger question, and I cannot speak for the Fabric Foundation, who are the intrepid consortium of developers and technologists who will take Fabric forward.
Yeah.
So I cannot put words in their mouth. But I would certainly hope that a big part of Fabric is payments and governance and coordination of human-machine teams to jointly accomplish particular tasks, as well as other functionality that's required. For example, the evaluation of robot performance by humans, and also allowing humans to help robots learn. But that's something where I would imagine the Fabric Foundation will be able to give you more specific information.
Gotcha.
And a white paper should become public relatively soon, should be public very soon.
Awesome. Yeah, look forward to that. Another question would be, under the whole umbrella, there are OM1 as an Android of the whole global humanoid, and also there are Fabric Foundation who are doing the decentralized layer one in a sense. How do you see those two products going forward? Are they like two very independent pillars for the humanoid industry, or they have some kind of a by nature interaction with each other?
There's two ways to think about this. What OM1 does is make an individual machine smart. What Fabric does is helps smart machines work together well and safely. So those are the technical differences. And there's also a difference in timing. Right now, the number of humanoids running around San Francisco is very small. So it is a little bit premature to think about, scalable infrastructure for machine-machine teaming. So the way this will play out is more and more people will have more and more robots. Those robots are getting smarter. And once that wave is gathering strength, then it will become apparent that robots can be even more useful if they're able to coordinate with other machines and do stuff together. And at that point, it will become clear just what an important piece of the technology stack this machine-machine teaming system is. And at that point, Fabric will be mature, and those capabilities are certainly already baked into OM1 itself. So every robot that uses that particular open source software, there's a lot of stuff already baked in, support for Coinbase Wallet and support for Circle payment, geo-gated payment systems, and various other functionality is already built in there.
Well said. Yeah. So basically, one is for individual performance improvement, and the Fabric is for the group collaboration globally.
Yes. It's basically how do you get humans and robots to work together efficiently and safely?
Cool. Thank you. Yeah, I think I covered pretty much most of the question, and I have the very last one. Can you put a little bit commentary on if there are some parents, ask you what kind of major shall we pick for our kids? They're gonna go to the college very soon, under this AI age. So that's, one group of the people. And another group of the people is like, for the younger generation who just graduate and what kind of industries they want to get into. Yeah. So could you provide some advice on that?
So unfortunately, I don't even know what to tell my children. And my
How
older
old is our
son,
kids?
14 and 16.
Oh, in the middle school. Okay.
High school. And Sam is actually, older one is applying to college right now. So he's
Oh,
writing his application essays. And I literally do not know what to recommend to him. It was really easy 20 years ago. You became a physicist or a computer scientist or a
yes.
dermatologist or a dentist or a lawyer, and you were probably going to be okay.
Yeah.
But now it is much less clear. There's one thing I like about how Stanford thinks about education, which is in the old days, after high school, you got a college degree, and that was it.
Yes.
You then crossed education off the list. And that almost certainly that idea is completely dead. The idea that is much more relevant is this notion of lifelong learning. And so this is the notion that every single one of us for the rest of our lives will have to pay attention to what's going on around us and learn new things. So this old notion of, you acquire one skill set that takes you through your entire career, that is guaranteed to be dead. So I cannot give you a recommendation on like what to major in. Anything I would say is probably dumb. If I told you, go get a degree in AI, like what does that even mean?
Yeah.
And what is the best skill set to prepare to contribute to AI? Maybe it's applied math, maybe it's philosophy, maybe it's something else. So I'm very reluctant to give like one specific recommendation. But the one thing I know is that everyone listening to this and all of our children are growing up in a world or working in a world where you have to be extremely nimble. And the expectation is that you spend part of every single day learning something new.
That advice is for the high school student, but also for the people who just graduate. I mean, for graduate students, what's your advice for them to pick the industry?
Unfortunately, I don't even have a recommendation about a specific industry, but there's a pattern I'm seeing. And the pattern I'm seeing is that the recent graduates that do extremely well, they all do one thing. So typically they have, some kind of tech background, and then they get on an airplane and then they fly to a place where there's a lot of interesting stuff happening. It could be San Francisco. It could be Shenzhen. It could be Hangzhou or Beijing. So get on an airplane, surround yourself with other people who are inventing or building the technology. So go to one of those hotspots and then hang out with a lot of these people. For example, here in San Francisco, what Stanford students do when they graduate, they immediately leave Palo Alto and move to San Francisco. And typically what they do is they move together in a house with their friends. And these are called like AI houses or hacker houses. And so there you have a situation where you're surrounded by other people trying to invent and build. And those can be very creative, productive environments. So that presupposes that you're willing to get on an airplane and you're willing to invent and create, and you're willing to do it like by yourself. And that set of decisions and capabilities I've seen generally work out really well.
So basically just to go to a place where innovation happen and surrounded by all the smart people.
Surround yourself by smart people, surround yourself by people that are smarter than you are, surround yourself by people who have different experiences, and go build, go invent, go start something. Everything is up to you. You cannot sit there and send out 800 applications on LinkedIn or passively wait for someone to offer you a job. It's your drive that will figure this out for you.
I was about to ask, whether the Ivy League is still worthwhile to fight for the application, but I guess you answered already. Ivy League or good college in the end, doesn't necessarily can teach you more than the ChatGPT, but, you will be surrounded by the smart people and where, innovation will happen, right?
College and university degrees were never about the teaching. One of the very valuable functions that like Harvard and Stanford and other leading universities play is they select the very small number of people who are doing something interesting. And so the purpose of the university is not necessarily to teach, it's to read thousands of applications and pick out the students that may have some combination of interesting skills. And then you bring those people together, and then it's almost irrelevant what you teach. It's just the fact that you found those people and put them in one room together and give them resources, and then interesting things happen.
It is another concept of innovation hub. Like smart people go together and, the catalyst will make everything happen.
Yep, exactly.
Okay, cool. Thank you. Yeah, it's a fantastic conversation, and thank you for sharing today.
Absolutely. This has been a blast. And if you need robots, software, or anything else, drop by San Francisco, come visit, say hello to all the robots. And if you have extra time to help build, please join us on the GitHub and start contributing to the architecture to make machines smart.
Thank you. Yeah.
Thank you. Good night, Bill. Thank you.
Cheers.
Bye.
Thank you for watching Build It Up. If you enjoyed this episode, don't forget to hit that subscribe button, drop a comment, and share it with a friend. And if you'd like to catch more stories and insights, you can follow me on LinkedIn, X, and of course, right here on YouTube. I'm Bill Chen. See you in the next one.